Hi everybody. So I'm just giving you a few instructions about your second assessed experiment. Your second assessed experiment is found in your practical booklets and it's to do with spring constant. Now the formula associated, the theoretical formula here involves the letter K, which is the spring constant, and we have not provided you with the value for the spring constant, and you've got to find that first, and this only will take about 3 or 4 minutes of your time, and I'll show you how this can be done using F equals Kx, and I'll show you how you're going to calculate that. The main part of the experiment is to find the relationship between, you can read it, okay, between two other things. So don't waste a lot of time on this, just spend about 4 or 5 minutes on it. So the first thing you need to do is you need your retort stand, and if you can see, I've clamped a ruler over here, and parallel to the ruler is my spring, okay? Now you need a couple of other things. You need a second ruler, and I'll tell you why you need a second ruler, and you also need some mass. Now the first thing we need to do is we're going to figure out what's the mass that we're going to put on the string. So this is a mass stack, and the mass stack itself is 50 grams, as you can see, okay? Each of these masses is also 50 grams. So let's count how many. So you've got 50, 100, 150, 200, and then that one is another 50. So you have altogether 250 grams. And I'm going to just write that on the board here. So my mass in kilograms is 0.250. So it's 250 grams, which I've converted to kilograms. Now I wouldn't want you to find any uncertainty for mass, just take it at its value. The only uncertainty I would like you to have is for what we're actually measuring, and that's the uncertainty for extension. Okay, so, and then what we need to do is we need to convert this mass to a force. So I've just got my calculator here. So I'm just going to get that 0.250 times 9.81. So I get this value, which I'm just going to put under the force. It's 2.4525. So this is 2.45. We'll do 3 significant figures. Okay. Now, in order to get my initial reading, so I'm going to hold it at the bottom of this hook here and align it with my ruler and see what I get. So I'm getting about 443 millimeters. So I'm going to just write that here. So that's 443 millimeters. And then I'm going to hang this hook with the masses. I haven't changed anything. And what's going to do is it's going to come down, it's going to get extended. Okay, so I'll just tilt this camera a little down so that you can see what I'm doing. So it's got extended. And then I'm going to get my final reading, not from the bottom here, because my readings are all from the bottom of the spring. Okay, so this is about 548, trying to avoid parallax error. So my new reading is 548 millimeters. I'm going to focus this on the board so that you can see what I'm doing. Let's project that correctly. Okay, there we go. So my extension is the difference between these two readings. So take that out of the way, okay, for a little bit. Okay, so I just go 548 minus 443, so 548 minus 443, and I get 105. Okay, so I get 105. I want that in meters, so this is in millimeters, so it's 0.105. Okay, now I'm going to use the formula F equals Kx to calculate the value of K. So this is F equals Kx, or K is equal to F over X. My force is 2.45, and I'm going to get my extension with an uncertainty, and my extension is 0.105 plus or minus 0.001, and you can work out the value of k. So I leave that part up to you to work. Okay, so that's the first part of the experiment. This shouldn't take you too long. The next part of the experiment is the main part where you have to gather data. And so at this point, you can remove this ruler here. We don't need that anymore. And it's to find, you need to find the period. So in order to find the period, you need to bounce the mass up and down. So I'm just going to lower this to show you what I'd like you to do. So one period is a complete up and down motion. So you can choose to start timing. Don't start timing the moment you release it. Allow it to oscillate freely for a bit. And you can either do timing from the bottom all the way up and back. That's one period. Or you could choose from the top to the bottom and back up. Okay, now when you're displacing it, you need to be really gentle, and you need to make sure that you just displace it. So just hold your finger lightly and just push it down a little bit. Now that oscillation is enough. Just make sure your oscillations is as linear as possible, and observe whatever you can while you're doing the experiment, because that's what's going to help you in your discussion. Okay, so observations are important. Make sure your report is your own report. Okay,